Hi, I'm Tim Zacharias with Cougar USA and your host of Building Value. Got a great episode for you today. It's actually part one of two parts with Christoph Lohr, Vice President of Strategic Initiatives for IAPMO. We're going to be covering a lot of different topics. On this first episode specifically, we're going to be looking at his background and also talking about the water demand calculator, which is about a 5-year effort to redefine Hunter's curve in the way that building water demand is calculated. And then we're also going to be talking about the Water Demand Summit that's coming up in November. On Building Value, we go behind the scenes of building operations to showcase the people and products that make buildings work and the value they bring to the community. Well, can you tell me a little bit about where you grew up?
Yeah, so actually, I guess I'm a little bit of a person that's all over the place. Try to keep it a little bit short, but I was born in Wiesbaden, Germany, and immigrated to the U.S. when I was 3 years old, and grew up in the Detroit metro area in a city called Rochester, Michigan.
Okay.
Went to high school, elementary school, high school, all the way through. And for college, then I decided actually to go south to the Virginia Military Institute, where I graduated with my Bachelor's of Science in Mechanical Engineering. Then spent a couple years out in the Midwest, living right on the border between Iowa and Illinois for the first couple of years in the Quad Cities.
Okay.
And then made my way out to Phoenix about 12 years ago and have been here ever since. Been out in the desert and learning all the uniqueness of that coming
Sure.
from green areas. But it's interesting. You sit there and you talk about water, and obviously we're going to be talking a lot about water today. And you get definitely a very different mindset when it comes to water, and how it relates to the importance of it when you live into a desert, and sometimes how wasteful we've been as a society and as a country, especially comparing to others out there. So.
Sure. Yeah. I mean, Phoenix is a beautiful area. I mean, only been there once, but definitely enjoyed it. And I feel like the kind of the last time we were talking about, you had some unique interactions in college that kind of impacted the way that you moved through your career and kind of specialized in what you are now.
Yeah, no, that's a great. Thanks for reminding me about that, Tim. My background again, Bachelor of Science in Mechanical Engineering, but it was interesting. My senior year, actually, I spent in a class, Energy Conversion Design. Still have the book up on my bookshelf up above the camera here, and in essence, the class was a whole semester on parallel piping systems, selecting pumps, and looking how open and closed systems that had parallel branches worked. And so I had a whole semester in math CAD basically, where we looked at the concepts of Hardy-Cross, Hazen-Williams equations, and everything else. And since I graduated VMI, I've noticed that not a lot of colleges or a lot of the engineers I've interacted with had that kind of opportunity.
Yep.
Early in my career, I was a sort of a mechanical engineering generalist. So I did HVAC and plumbing design. And I would liken it to, there's a mechanical coin inside the building. One side is HVAC, the other side's plumbing. Even though for a long while the industry has sort of thought of it as, plumbing is subservient to HVAC, which I think is unfortunate. I think we've have devalued and kind of had a lot of missed opportunities for some positive things in public health and safety. I think that dynamic is shifting now.
Sure.
But early in my career, I did both. And then it was about 3 years in where I started getting into healthcare work specifically. The company I worked for, they split up their HVAC and their plumbing folks. And so at the time when I joined them, they only had an opening for plumbing. So I started with that and with the thinking, maybe I'll go into HVAC, go back to, where I was thinking where I wanted to be. And then I quickly realized that, a few months in that, man, there's a lot of opportunity here. To really be involved on the plumbing side and to focus on that. And it was interesting because my favorite courses in college were the theory side rather than the practical side, but all the theory side of that plumbing. And one of them was that energy conversion design course, where we really had spent that time on Hazen Williams and whatnot. And so I pretty quickly, about a few months in, I was like, I was originally thinking when I joined this company that I was going to go back to HVAC, and I was like, nope, I'm going to stick with the plumbing side. And so from that point on, I made another change to another engineering firm that really kind of helped propel me. But really spent the last half of my career focusing on the water, medical gases, but especially in the water and water safety standpoint, because what I started noticing was there was a lot of non-systems thinking, I guess, if you will. It's something that I speak a lot about, and that is the idea that we're looking at in the engineering in the U.S. My sense is that we tend to think things in tasks. We're very task focused.
Sure.
So we have great products. We have actually, it's interesting when you talk to some of the folks overseas. They a lot of times they want to learn from us in our product development, because I think we are able to make componentry that's much better. But when it comes to the overarching how those components interact with each other, I think that's where we struggle. At least there's a lot of room for growth. I think that's a fair way to put it. There's a lot of room for growth on our side.
That is a polite way to say it. Yes. I was going to say, I mean, it seems like you said before, you really enjoy where you're at now with IAPMO and kind of getting to take all of this experience that you've had in the, practicing as an engineer, being in that industry, and now kind of being in more of a, I guess like the code standards or advisory type role, kind of guiding where the industry is going with what you're doing now.
No, definitely. I feel very fortunate to be with IAPMO. It's a great organization. They really care about public health and safety. I mean, that is the number one driver. We have, I was going to say, I have one of those stickers on my thing, live by the code. And I love it. It's this pointing to, we're impacting people's lives every day we come into the office. Warranted, I work from home. So, my office is right just downstairs. But to me, I've always been kind of naturally a more big picture thinker. And so I think I struggled early in my engineering career because I tended to be a more big picture thinker. I had to learn to do details, but I think that's kind of the case for any big picture thinker. You have to learn the details. You can't just not know them. And I think it makes you more effective, as you progress through your career and learning the details, maybe the back end of the career. I do feel the last 6 years have been a little bit easier than the first 6 years. But it's been good, and it's a growth process, and you have to cut your teeth somewhere. And so I think for me, especially in the role I'm at now with IAPMO, getting the chance to the way I look at my role, it's being that public spokesperson for the plumbing industry, getting the technical information out there, sharing what I know, but also when I share what I know, being open and receptive to other people's ideas and thoughts and insights, and pulling that into the work, and then finding ways to get the industry to kind of collaborate better together.
Sure.
And bring diverse groups of people together to really make these new ideas take flight. And getting, and right now a big part of what I'm trying to do is focus on this idea of systems thinking within plumbing, and trying to break down the silos, getting people talking, and then starting initiatives where we have people that are working together that maybe hadn't before. And getting documents created, guidelines created, manuals created, testing criteria created that push the industry towards the betterment of public health and safety. And I think there's a lot of opportunity in plumbing right now. I think when you look at the amount of growth that has happened in plumbing over the last 5-10 years, especially because of the concerns of water safety and specifically waterborne pathogens and Legionella. It's far, in my estimation, it's far outpacing HVAC and electrical changes right now. And so I think there's a lot of room for growth for the plumbing industry. And that gets me really excited. I mean, definitely gets me out of bed because I think there's a lot of positive developments that will happen for the U.S. as a result. Yeah,
for sure. And I think in general, the public is much more aware of water safety these days, where the water is coming from, how it's being treated, I just think it's not just something that people are turning on the tap anymore and getting water and taking, maybe a little bit taking for granted how it gets there, but, maybe thinking about what's in the water or just general water safety like that. So just real quick, though, for anyone who might not know what IAPMO is, can you just give a brief description of what the group is?
Yeah, certainly. So IAPMO is the International Association of Plumbing and Mechanical Officials. IAPMO for short, IAPMO.
Yeah, it'd be a mouthful if you had to say that every time.
Every time, I know. So we always usually go by the shorthand. But it is a code and standards developer. So we develop the Uniform Plumbing Code and the Uniform Mechanical Code, which are both follow the ANSI process. And I'll touch on that in a moment here, but we also do product testing. And so we're a nonprofit, so we are very much third party. And a big part of our role is to get the industry together to come up with the best process forward. And so we, whether that's for product testing, which is a big part of what we do, we make sure products that are safe. If you've ever looked on like your faucet, or any device that you have, not all devices have it listed there. Sometimes they just put it on the sheet, but sometimes they'll put it on the physical part. But if you see that shield with UPC or IAPMO, that's one of the products that we've tested. And that's, those standards, those testing standards are something that we put into the code. So we do a lot of that, but we do more than that too. I mean, we now have a philanthropic arm, IWISH, the International Water and Sanitation Hygiene Foundation, which is our philanthropic arm that does, really great work across the country and the world and bringing water and sanitation to people that don't have that advantage up there. So we've had projects at the Navajo Nation up in northern Arizona. We've done stuff in South Africa and Southeast Asia. Really great group of folks. And then we have a presence overseas. We do stuff in India, and again in the Oceania Pacific. We have an association portion, so we have members as well that partake. And so it's a really great organization that really focuses, from a big picture standpoint, again, codes and standards and the product testing predominantly, making sure that, our water and HVAC systems are safe.
Yep, absolutely. And I like you keep mentioning the systems approach and this whole idea of, looking at the entire system. And that's something that we definitely try to do as well, and pride ourselves on the knowledge of the entire system. And, if we make changes to this one component, what's the effect on the whole system? Or, we get to the hot water distribution discussion here a little bit later. We'll get into some of that. I mean, but, there's oftentimes when somebody says, well, it's, the idea or the issue is pointed at a specific component when it may be just a sign of a bigger part of the whole system. So definitely appreciate that point of view. And I think one of the other big systems that I want to talk with you about, something that I'm pretty excited about, is the new water demand calculator and this idea of finally maybe moving past the hunter's curve days of yore, right? So I'd just kind of like to get an idea of where kind of all that came from, and maybe give us a little background on the hunter's curve and how we kind of got to where we are with the water demand calculations for a building.
No, definitely. So, so when you look at a building, and whether it's like your apartment where you live, or your home, or if you look at something bigger like your office or your university or hospital or sports stadium, obviously there's a lot of plumbing fixtures in there. So we're talking our faucets, our showers, our water closets, everything else. When you look at the building though, and you look at it from that water system standpoint, when you're sizing piping for that building, there's a few different ways you can do it. And the original method was to just say, okay, everything is on at the same time. Now the problem with that is, what's the worst case, right? But the problem is, if you do that, if you had, and we'll keep a smaller, simple, thing. So like a large, like a sports stadium or a hospital is going to have thousands upon thousands of fixtures. Let's just say, we'll keep it simple. We'll say it's a smaller office building that has, 10 water closets, 10 toilets, they're the flush valve type. Typically a flush valve operates at, 25 GPM. And if you look at the fixture unit, the flow rate of that, if you assumed all 10 were on, you'd have 250 GPM. Well, what's the likelihood of all 10 being on at the same time? Very, from statistics.
That 25 GPM is very much an instantaneous demand, right? It doesn't last.
Yes. No, and that's
period,
that's
right?
the other part of it.
Yeah, and so it's not just the pipe, right, that ends up being oversized. I mean, everything in the plumbing system gets based on that worst case scenario, and it drives pump selections, the piping, like you said, everything to that worst case scenario.
Well, and that's the part too. When you look at the pipe size, again, we're counting for a peak flow demand, but like as you mentioned, most of the time you don't have that kind of that kind of flow rate. You typically, most of the time, your plumbing fixtures are off. I mean, if you look at them, they're either on or off. Most of the time, they're off. And so what Roy Hunter in 1940, in essence, I mean, this is how old the sizing methodology is. In 1940, he concluded a couple of studies, and basically he took a 99.9 percentile. So what does that mean in English? So that means he says, okay, there's a certain probability that at any given moment that a number of fixtures are going to be on at the same time while others are going to be off. And so 99.9 percentile is a pretty high usage. It equates to, imagine if you had 10 fixtures, whatever they were, somebody using the fixture, stepping away, like washing their hands, let's say, you have a faucet. Somebody washes their hands, steps away, somebody immediately gets up into the fixture, turns it on, starts washing their hands, turns it off, steps away, and then somebody right after that comes onto it. Well, there's only a few building types in the world that really work that way. And that's sports stadiums, theaters, and
where you have a rush of demand. Yeah.
Right. Airports, when a flight gets in, it's not even the whole airport that works that way. It's right. Typically certain times of the day. But a sports stadium, but that was an ingenious solution in 1940 because he didn't have a computer to run any kind of, numbers. He did all the calculations by hand. And he was able to figure out, okay, if I get this 99 percentile, condition, I can really drive down the size of the system.
Sure.
So, to take a look at, if we were to do, if we were to kind of equate this, to our continue on. So, if our example before with 10 water closets, at 25 GPM, if they were all on, you'd have 250 GPM of flow rate. But, we don't want to assume that. So Hunter, he basically, with his curve of utilizing a value that included the flow rate and the probability of it being on or off, that's what the fixture unit is. It's a dimensionless unit. You're able to convert into a projected 99.9 percentile flow rate, which in this case, for our 10 water closets, it drops it from 250 GPM, something around 50 GPM. So huge. I mean, it's a fifth of the flow rate, which means
it's a big drop.
You're going to likely go from what, like, I'm trying to think here right on the fly, like, 250 GPM is probably like a 4-inch line, something like that. You're going to be able to drop down to like a 2-inch. I mean, so you're talking a lot of material, and that's why the U.S. Department of Commerce had hired Roy Hunter, was to try to make it more economical to build buildings. That the original reports were all by the U.S. Department of Commerce. So that's where we started. So he basically finished that in 1940. 1945, he was doing the same thing for drainage fixture units, and that's when you'll see that report was released. And then he died. 1945, which is why we have the GPM on water side, but we don't have it on the waste side. It's because he never finished the report. And I learned all this through my amazing colleague, Dan Cole, who is like, he'll probably cringe when I say it, but he's like the world's foremost expert on Roy Hunter. I mean, he's written so many articles. They're definitely worth reading. I've been fortunate enough to work with him and over the last a little less than a year. And he's taught me so much. A really great guy. But again, in 1945, it all stopped. And then the U.S. Department of Commerce kind of stopped the point of it. And then you look at the years afterwards, and when plumbing codes really started coming into fruition and really starting being developed, and the Hunter's curve was embedded in each one of them. Mm-hmm. And so it became codified, and that became, again, code is the minimum requirement. And so that became the sort of the de facto way of sizing water systems, was on a sports stadium concept. And so pretty much buildings for the last 80 years have been all sized like, regardless of type, have been sized like a sports stadium. So that's the context we're kind of dealing with, from a water sizing standpoint. Now, the plumbing engineering and plumbing contractors and inspectors, the entire plumbing industry, manufacturers, we all realize that it's oversized.
Yep.
And nothing, it's always been kind of a tall ask to get anything to be done about it. In part because it hasn't been a priority. Now, in the last 10 years, especially as we're realizing that water quality concerns, and then we can talk about this a little bit later, but there's water quality concerns that come as a result of oversizing. There's material usage issues now that we're experiencing, post-COVID. The cost of construction has gone up because a lot of materials have gone up. All those things have kind of bubbled to the surface, and sustainability initiatives too. We've reduced our flow to a lot of fixtures, which we need to do. Yeah, I mean, I live in Arizona, but we haven't gone back and evaluated our pipe sizing. And so that will help with the sustainability side and with the safety side. And it's my core belief that what IAPMO has come out with in the last 6 years, which is the water demand calculator, is one of the first steps and is a great solution that can potentially help impact both in a positive way rather than having us push and pull. So the water demand calculator, which came out in 2015, was completed by a task force of IAPMO, the University of Cincinnati, and the American Society of Plumbing Engineers. And they created a task force that worked on residential buildings. And that residential buildings, basically, they collected data for many years, I think hundreds, if not thousands of data points. And basically by utilizing a different methodology, and I won't get into all the nitty gritty of it, but looking at—
give away all the secrets of the summit, are you?
No, not all this. That'll be one of our other points here. But in essence, they were able to reduce the probability factor and make it more in line with what you would expect to see in a residential building. Yeah. Which is huge. Residential buildings, when you consider single family homes all the way up through multifamily and high rise, it accounts for a huge part of the buildings in the US.
Yep.
And so they were able to reduce it pretty drastically. As an example, I ran the calculation for a bigger high rise. And my former example of like 10 water closet. Imagine a building which has 200 units of inside of it. So probably a high rise apartment complex. With the Hunter's curve, that would equate, those 200 units would equate to about, probably like 200, 300 GPM. So we're talking our 4-inch line, right? Yeah. Because we're talking like hundreds of water closets. With the water demand calculator, utilizing that specific example, when I ran it, the peak flow rate went down to 50 GPM.
Yeah. And I believe that, right? I mean, we see this all the time in the aftermarket and in new construction, we're working with engineers and seeing these big flow rates, especially in the multifamily, like you're talking about, really, really high flow rates. And it's not just the pipe size, like you said. I mean, the two areas that we see where it becomes a big issue, especially in high rises, are the booster pumps and the pressure reducing stations. So you have oversized booster pumps where they're sized for that worst case, trying to work them back at that partial demand. It doesn't work very well at all, right? You have all kinds of control issues, and then PRVs being oversized causes a whole nother set of problems. But in our experience, in some cases, that diversity factor or probability factor, like you said, is as little as like 10 to 15% of what Hunter's curve would predict for that building, right? I mean, it's a huge potential savings to the point where we've had. We did a temporary pump on it was a 400 unit, it was a student housing. So 400 units each with 2 bedrooms, and a pump that can't do more than about 100 to 115 GPM carried it at basically 99% occupancy. Right. Wow. So I mean that flow rate that you're talking about, the number that you gave is right on, I think, with what we've seen in real life examples. Just that diversity of use is a lot bigger than what people think.
It is. Well, and that's because most buildings don't work like a sports stadium. It kind of goes back to that. It's interesting. Your example reminds me of an engineer that I've worked with. I had the pleasure of working with pretty closely over the last year plus, Gary Klein, and he's actually he's presenting at the ASPE Technical Symposium coming up here in San Diego, and he's kind of talked to me a little bit about some of the stuff that he's looked at, and he's actually working on projects in New York, where he's utilized the water demand calculator, and they're going back and measuring, and they're finding that the water demand calculator is still oversized. So there's a safety factor involved with it.
Okay.
But it's, instead of it being like 500%, it's like 50%. Yeah. And that's huge. I mean, that's a huge impact on and it's not just about getting the pipe size smaller and saving money, although we have a report that talks about the potential cost impact savings. But you start talking about water quality and sustainability, and how the building performs, and you mentioned booster pumps. I mean, if we're able to get the right booster pump size in there, instead of having like a 10 or 20 horsepower pump, if you get a 5 horsepower pump, now you're talking energy savings. I mean, this goes right towards decarbonization, right? I mean, this has been huge. So we have now, a solution that is it's not just pulling on one lever without considering the rest. It's more holistic. We're looking at how all these things integrate, and when it's a much more thoughtful approach, a more holistic solution, to kind of use that wording again, where you're looking at the system as a whole and coming up with a way to solve multiple variables at the same time, solving multiple problems at the same time, with minimal negative unintended consequences on the other side, or none at all. And I think in this case we have one that it's neutral on the negative unintended consequences.
Yeah, I can't really think of any. I mean, unless you were to go extreme and come up short on the pump selections, but I mean, I don't know that really ever happens.
Well, and it would be a short period of time, if that. But again, we're talking such a low likelihood and probability, and we're talking about something, again, when you think about the building, most of the time the plumbing fixtures are off. They're off 99% of the time, and they're on 1% of the time.
Yeah, and especially if you don't have a cooling tower, right? I mean, if you take a cooling tower out of the building, there's probably 60 to 80% of the overall use, right?
Yeah.
So, you take that factor out, even more so, you have less risk, right? I mean, when we're doing, sizing a booster system or something like that on a retrofit, and we're looking at downsizing from what's there, it's one of the first questions we ask: does this make up to the cooling tower? And, from there we know where we need to be. But it's funny that you'd think the company that's providing and selling the booster systems, if they're suggesting a smaller one, that they're not trying to pull a fast one on you, right? Like, we're trying to talk you down from this massive booster system because we know that over time it's going to cause issues, right? You're going to have failures. You're going to have unhappy tenants and guests and patients, and we're there for the long haul, and so I'd rather take the smaller sale and have it be the right fit for the building.
Yeah, no, I think so too. Well, and I also think for the industry, though, obviously going smaller can be better, from a quality standpoint, less callbacks, less, service calls and all the rest. But I think also, you look at the opportunity for improving the dollar per unit value of whatever. I think that's out there too. I think if we can go with smaller components, but they have more features, they have more benefits, it makes the owner's life that much easier. I mean, that becomes a win-win. And I was going to say that becomes a win-win for everybody, for the owner, for the engineer, for the installing contractor, for the manufacturer, for everybody involved from start to finish. Mm-hmm. And that, I think, is looking at it from a systems-based approach. You're now looking at how all these things kind of interact, and you're coming up with a solution that is holistic. Again, holistic meaning there's a long-term positive impact. In some countries, like Germany and the Netherlands, they've been doing some of this for a while, and it's kind of interesting as I've kind of started, looking back at my and started reading on some of the stuff that Germany's doing. They've been doing it for a lot longer than we have, and have been able to get some really positive results as by that methodology.
So, how can people utilize this water demand calculator? Where do they go to use it?
All right, so if you go to www.iapmo.org/water-demand-calculator / that'll take you to the webpage directly, where you can look at all of our reports. You can download the latest version of the water demand calculator. It's in Excel 2.1. There's even a how-to manual right there. And basically you fill out your total number of fixtures. You click the run, the run feature, and it will give you what the approximate diversity factor is. It'll give you the estimated peak flow rate. And again, that's still, we're finding as we're kind of going back even for larger buildings and revalidating, because we already validated this, but as we're going through and revalidating this, that it's got that little bit of safety factor in there. So it should give everybody a little bit of confidence. And then obviously if you have like a cooling tower, you'd add that GPM on top of it. I think it's the most common engineering practice, but there's also our studies. There's a study from the AWE that talked about the potential positive impact on water meter downsizing. There's a study we did a study with Stantec that talked about the material costs, which we found for single family homes up to a 45 unit multifamily, you could expect, and this was pre-COVID numbers too, estimates, but depending on the market, you could see material cost savings of anywhere between up to 10 to 16%. Wow. So, I mean, that was, again, material costs are much higher now. So the difference we'd expect to see that likely go.
It's a significant number. Yeah.
So, and again, you start talking about like a big, building. I mean, it starts adding up. And I ran the calculation. I kind of looked at it for that 45 unit. I mean, between the connection fee and the pipe material cost savings, based on those reports, I think I was seeing like up to around high end of $200,000 in savings as an example on the project. So it's not a small chunk of change. It definitely
that assumes that the municipality has, everything right there. It's not, you're not having to make the connection far away, or it'd be a much larger connection that's typical for the area, right? Like we worked with a major gas station chain. I won't specifically name them, but they are, all the bathrooms is a big deal there, right? And so that's one of these more potential stadium type uses, right, where you have all these restrooms always in use kind of deal. And they were under the impression that they needed a certain size connection from the city and a certain size meter and all of that coming in. And we were able to show them the flow data on the booster system and go back and say, no, you really don't need that much. And it was a significant savings from what the increase of the pipe size was going to be. So
it's massive.
Absolutely.
It's definitely massive for sure. So, the other part of it too, that was interesting to me with that 45 unit example that I gave was the annual savings too, because typically most water purveyors and sewage departments, based on your water meter size, they'll charge you different rates. So for that example, there was like $10,000 per year in
savings.
Yeah, $10,000 in savings like year after year after year, which was just, again, mind blowing. I think it was like 1,600 or 16,000, in savings year after year. For that 45 unit example, up to. That's a high number, right? So it could be lower than that, but it was staggering to see. It's a lot of money. So this can definitely help, in terms of an economic standpoint.
For sure. So I'm curious. I want to ask you about the summit, but it's an idea that I wanted to bounce off you. Conversations I've had with another guest, Mike Fair, who's like a water quality kind of chemist expert, way smarter than I am. I didn't understand half of the stuff he said on the podcast, to be honest. But one of the things that I did think was interesting was the idea of circulating the cold water loop. And I'm curious what your thoughts are on that. You can talk about the pull, push and pull of safety and energy savings, and the example of the hospital not wanting to use low flow fixtures. If you were to take that same building, use the low flow fixtures, but have a recirculation line on the cold water so you don't get stagnant water, do you feel like what are your thoughts on that type of a design?
I am very interested in this. I'm actually speaking about this subject in a panel discussion at the ASPE Technical Symposium.
Oh, nice.
I think there's a lot to evaluate in that. From a water safety standpoint, I think that, keep in mind, if you look at like the tip of your pen or your pencil, to a bacteria that looks like a football stadium. So any increase in surface area, whether by length or by size, there's a potential for more spots.
Sure.
However, one of the bigger and additionally big concern is when you have uncirculated or areas where the water age increases. And so, the only option to get water circulating or water moving, I should say, doesn't have to, circulation is one option, or recirculation, but is to flush, basically open up your faucet and flush it to drain, or open up your water closet, continue to flush that to drain, to move the water in those areas. But as we found out during COVID, where a lot of buildings were sitting vacant, and then we worked with AWWA to create a sort of a report on management of buildings or ideas for stagnant water. So that was a separate one, but AWWA approached us and we worked with them to create a responding to stagnant water in buildings, sort of a guidance document. And that's a problem because flushing really is your only option. What I've been thinking about a lot is, we have a lot of buildings that are sitting vacant and they're in areas like the Western U.S. where if you flush and it goes to drain, what do you do with that water? Do you put in a gray water system? is there an option to circulate the water to make flushing, to get that distance between the circulated part, where the water's, quote unquote good, versus areas where it's deteriorated. And if we shorten that distance, does it make sense? So I think there's definitely a series of thinking that needs to occur. And I think there's potentially a case here for circulating the cold water and having some kind of water quality maintenance device.
Right.
It's definitely worth exploring to maintain that water quality and then reducing the amount you have to flush to drain. Right. I think it's something we need to be looking at. Now, I will say countries like Germany, I'm aware of technologies that are coming out of there. They're already doing this.
Yeah.
Now, that's one of those differences I was kind of alluding to earlier. And I've had conversations with people that are for and against this line of thinking. But in Germany, they don't have as much chlorine in their water. They actually have very, very low levels of chlorine. But they're looking at water temperature and sediment control and other water quality requirements outside of just straight up, adding disinfectants to the water to try to control. But they've done it in conjunction with making their pipe sizes smaller as well. And they've been doing this for a long, long time. So one of the things, the Water Demand Calculator Summit that we're going to be hosting, we have a couple of folks that are going to be talking about that methodology and what that means and how it works. And what are some of the positives and negatives of that approach? So I think that there is definitely a lot of exploration needed in that topic. I think there's a lot of potential in that.
Sure.
I think we just got to be mindful that there's differences in cultures and how we do things here in the U.S. versus how they do things in other countries. And again, thinking of it in terms of systems, how does this all play into each other? Does it make sense to do this? Although my sense is that there is something we can learn from some of our colleagues and professionals on the other side of the pond, as it were.
Yeah, absolutely. I mean, I know it almost starts to mirror what we're doing on the hot water side of the building, right? When you start talking about having a return loop and adding in water quality, and you're starting to kind of look at what the ASHRAE 188, Guideline 12, all of that, having the multiple layers of defense against Legionella and other bacteria. I mean, so it definitely starts to open up this whole other set of questions of what you're going to do on that side of the building. But I would agree that there's definitely potential to do that versus just flushing. And
yeah.
I could tell you, even in like our office here, in the bathroom in our workshop, that when I was coming up here like once a week to do virtual training and stuff like that, that bathroom rarely got used, and we had the Spartan Cube to be able to do Legionella testing on site.
Yep.
So I was basically learning how to do it. Took a sample out of the sink in there, and we had Legionella. And I was like,
oh, jeez.
Okay. So luckily it was a very low amount,
Yep.
But it was detectable, and so a simple flush and we were back to normal. But like you said, there wasn't any other option other than to flush the line.
Yeah. And that's kind of where we're kind of, as I mentioned before, there's this little bit of dichotomy, and there's this pendulum that I've noticed swinging. And I think early in my career, the pendulum had swung very, very much over the sustainability side. And I think it was a good thing. That we're focused on that, but just like anything else, we need to find that balance. But now the last 5 years, I've seen it swing completely the other way.
Safety.
About safety.
Yep.
The problem is, we need both, and that's where I had recorded a podcast with Marianne Dickinson, the president and CEO, former president and CEO. She's now retired, of AWE, and Dr. Janet Stout, the head of Special Pathogens Lab. And I think it was Marianne that had mentioned, creative synthesis, finding ways to get these solutions in place that really work together and with each other.
Yep.
And it's a really key part. And the Water Demand Calculator Summit that's coming up on November 4th, I think we'll start that process. Right now the summit, or the calculator, only applies to residential, but obviously we have a lot of different building types out there. I mean, hospitals,
Sure.
hotels. And those ones have typically, higher they account for a larger percentage of outbreaks or cases of Legionnaire's disease.
Yep.
You have offices, right? Those have sat stagnant. And I think the office environment, with that changing, with remote work.
Oh, massive. Yeah.
Yeah. How's that going to, yeah. So how's that all going to get impacted? So I think it'll be really interesting for us to see what those, we have definitely a lot of study that's needed. And that's where, The summit that we're hosting here on November 4th, it's a virtual event, virtual summit. We are, in essence, going to have an all-day that talks about the whole history of Hunter's Curve. We got the original task force members coming in and talking about sort of the ghost of Roy Hunter, past, present, and future, if you will. Then in the morning, and then in the afternoon, the second half, we're going to be talking about kind of some of the challenges to get this stuff created. So we're going to talk about data analytics and data collection and Monte Carlo analyses. We're going to talk about what kind of data is out there already, and then we have an open panel discussion and participants, people that sign up. We're hoping to be able to give them a platform to speak and to kind of chime in with questions or share information. And then the goal of this is going to take to the task force to make it a task group and to expand it. And so we'll have a registration page likely available for people that are interested in being part of this movement. And that includes manufacturers, engineers, anybody that's dealt with the Hunter's Curve or sizing of equipment. We'd love to have you sign up for the task group and basically try to kind of get this crowdsourced effort of data, of collecting the data, of getting the information needed to take the water demand calculator and get it applied to other building types. And I'm really excited. I think we've had the registration page open for a couple weeks now. We've had a great initial run. I'll send you the link to that as well, Tim, for your listeners. We would love to have people come and sign up. The cost is $49, but the reason for that is very simple. We want people that attend this to have skin in the game. Sure. We believe there's going to be 6 CEUs offered for those that need it, but we also feel like, especially if we're going to open up the mic, and have people being able to talk, we want to make sure that the people that show up have skin in the game, and not that we just end up with somebody that doesn't necessarily care about it. So, we're trying to make sure it's a group of like-minded individuals that are trying to drive towards a common purpose. And really the hope is to take people that are interested in this, and then obviously there's no cost to being part of a volunteer task group. And we're making it that volunteer task group will be a virtual one. So again, we're trying to minimize costs. I mean, that's one of the lessons that we've gotten from COVID in terms of minimizing, we've been able to kind of do this volunteer stuff virtually, and we've been doing it before. But the goal is then let's get people talking, we'll get some subcommittees going. And in essence, we'll be able to really start that process. And I think there's some, as some of the initial conversations we've had in preparation, as we've been even just developing this summit, and some of the people that have kind of reached out as a result of seeing the registration page open or just conversations, there's a lot of people that are looking at getting involved in this. So I think it's a great opportunity to go from the Hunter's Curve to the plumbing industry's curve, and really kind of being part of something bigger. And that gets me excited as a big picture thinker, but also it gets me excited for the industry because it's now something that, I think you probably do it, with your family, and a lot, I think everybody in the industry, like myself too, when you have your significant other or your kids, you drive by a building. Oh yeah, I did some work on that building. Right? We all do it, right? Absolutely. I get the eye rolls from the wife, but my son still thinks it's cool for now. My son too. He thinks it's so cool, and I think we all do it, right? But here we have an opportunity to be part of a movement, really to make history together, which is our theme for this year's summit. We're hoping to make this an annual summit, but to kind of make history together. And now when we drive around town, any building that gets built in our city or our town, we can point to it. And especially, at some point, if we have this water demand calculator that touches every single type of building type out there, it's not just the ones that are product or engineering services, or we spent the time doing the install that we point to. Now we can point and say every building in town, we had a hand to play in making that building better, making it safer, finding ways to build the resiliency, impacting the water usage. That's the opportunity we have here. That's kickstarting with this. So I really hope, and I think we've had some great initial output that people can come in and be part of this movement. It's a crowdsourced effort. There's still stuff going on the side that we're doing, but if we can augment that, we just are speeding up the process. And looking at the way the world is today, I think that's the opportunity that's out there. And I hope some of your listeners and you, Tim, I hope we see you there.
Oh, I'm going to be there for sure. I mean, this has been something that we've been passionate about for a while, and live and breathe every day, going out and being in buildings and working with the facility managers and building engineers on their existing systems, and then also with the consulting engineers on new construction. So definitely this is a topic of interest for me, and I'll be be there and submitting some questions and stuff. I don't know if you be a good idea to open the mic or not, but I'll definitely take the opportunity if you do that. But no, I mean, I think it's a great way of going about it to open it up to all these other people, because I mean, I know the amount of experience that we've had with it, and I know there's a lot of other people that are out doing similar things, and so you get all those people together. I imagine you can get a lot of data and speed up that process. But I would agree. I think it's going to have a huge impact on the way that the buildings are designed, that the systems are designed, and ultimately the way that we provide and maintain equipment. And I think it'll be great to be able to walk in with a new tool, and it's not just saying, "Look, trust me." I know this piece of paper that's 80 years old says it's going to be this, but trust me, it's going to be really over here. So to have that kind of third-party verification, like you said, to say, no, this is really where we think it's going to be. This is actually where it's going to end up. And so to have that kind of accreditation. All right, well, that wraps up part 1 of 2 here on this episode of Building Value. Again, the guest today was Christoph Lohr, Vice President of Strategic Initiatives with IAPMO, covering the Water Demand Calculator and the Water Demand Calculator Summit coming up here in November. We've got links out to the website, to the summit for registration, all of that good stuff. So please check that out, and please check out part 2 of this episode that will be coming up in 2 weeks.